Alright, so section 2 is integration by substitution. So we've already kind of started this. But actually, before we do get started, I do have to mention a massive mistake that I made today in class. It was in the cone problem. If you guys remember when we took, let's see if I have it. If you guys remember when we took when we raised both sides to the 5/2. When we raised both sides to the 5/2, I did one of the most common mistakes that is done, and you cannot do this. Okay? So what I did is I said, oh, take the 5/2 of this, take the 5/2 of that, and that. You cannot do that. So this is actually the wrong answer. So, and you cannot take the 5/2 of each and every one. You have to take the 5/2 of the whole, or the 2/5, sorry, of the whole entire thing. So this actually is just negative 125t over 48 pi plus 10 to the 5/2. All of that raised to the 2/5 equals h. Because remember, this is the actual answer. Because remember, if you have x plus 2 squared, that's not the same thing as x squared plus 2 squared. So that was one of my bigger mistakes, but please make sure that you fix that. Okay? Alright, so now going back to section 6.2, which is on u substitution. So anti-differentiation, basically anti-derivatives, integrals. Anti-differentiation formulas do not tell us how to evaluate all integrals. For example, consider the following. Okay, so anti-differentiation formulas are basically the formulas that we already know. So what's the integral or the antiderivative of 1 over x? We know is ln of x. Or using the polynomial rule, the power rule. So for example, consider the following integral. The integral of 2x times the square root of 1 plus x squared dx. To solve this integral, we'll need to introduce something extra, such as a new variable. We'll define the variable u to be the function of x and then look for the differential of u. So first we're going to let u equal, and this is a mistake, cross this out, so u is equal to 1 plus x squared. So then du over dx is equal to 2x. And then of course when you multiply both sides by dx, you end up with 2x dx. So this is a little bit harder than what we were doing in class, because here you notice that there was a 2x dx. And the only way that you can integrate this easily is if you got rid of not just what's in here, but replaced what's out here as well. So our integral can now be rewritten in the terms of u and du. So instead of all of this, we're going to rewrite this next to dx. So it becomes the integral of square root of 1 plus x squared 2x dx. And now I can replace this with my u, and then this whole entire thing is going to be called du. And so what is the integral of square root of u du? It's just 2/3 u to the 3/2 plus c. And now of course you plug in your u back in, and you end up with 2/3 x squared plus 1 raised to the 3/2 plus c. So this is our answer. Now we can check our answer by using the chain rule to differentiate our final function from above. So basically all that means is work backwards. So find the derivative of this and see if you get what you originally had. So take the derivative of all of this, which means this guy comes down, right? So 2/3 times 3/2. This gets subtracted by 1. So you end up with x squared plus 1 to the 1/2 times 2x, because we're using the chain rule. So we're taking that center, x squared plus 1, and we're multiplying it on the outside, and you end up with what you had originally. So this method works only whenever we have an integral that we can write in this form, that the integral of the derivative of g of x times the derivative of g of x. So where f, you take the g of x times the derivative of g of x, and that's your function, equals f of g of x plus c, because the chain rule works in the opposite way. Alright, so if we make the change of the variable or substitution u g of x, then we have the following. Okay, I'll let you guys read this. Let's start off with some examples. So here's our first example. Basically, I'm going to let u equal 2x plus 1. So the idea always in these types of problems, when you're doing u substitution, you're going to look, I'm just going to write that over here, you're going to look for the most complicated expression involving your variable. Okay? And then trying to turn it into something. And then try to turn it into something. Alright, so here u is 2x plus 1. Du therefore is going to be, or du is going to be du over dx, right, is going to be 2x. Or I'm sorry, just 2. Now here, if we rewrite this so that we can get dx by itself, okay, we end up with multiplying both sides by dx and then dividing du by 2. So we end up with dx equals du divided by 2. So this is easy because all I need to do is replace. So now I can replace this part by square root of u, and then the dx is going to be written as du divided by 2. And if you remember from class today, that 2 can just come out, and we end up with 1/2 of the square root of u times du. So now what's the integral of the square root of u? Remember that u is the same thing as saying u to the 1/2. And so we add 1, divide by this plus 1, so you end up with 1/2 u to the 3/2 divided by 3/2 plus c. So there's our integral, but of course it's not cleaned up. So we take this guy, flip him, and multiply, right? So we have 1/2 times 2 over 3 u to the 3/2 plus c. The 2's cancel out, so you're left with 1/3 u to the 3/2 plus c. So because basically the integral of this was g of x, the derivative of u times the u times the derivative of u, because oh yeah, we're not done yet. I forgot to replace u. So it's 1/3 of 2x plus 1 to the 3/2 plus c. Sorry. So there's my answer. And because this follows this method, okay, so because basically the integral of the function of g of x times the derivative of g of x ends up being f of g of x plus c, we can check it. So we can run a check by finding the derivative of this guy, of dy dx. And remember, you take using the chain rule. So this thing comes down, so it's 1/3 times 3/2 of 2x plus 1 minus 1, so that becomes 1/2, and then of course times the derivative of the inside, which is 2. So once you clean this up, it actually becomes 1/2 times 2 times the square root of 2x plus 1. So the 2's cancel out and you're left with just the square root of 2x plus 1, and that's what we had right there. Alright, now I'm going to have you guys do the checks on these just because I don't want this video to go on forever. Alright, next one. So first off, our u is going to be the most complicated part, so I'm going to let u equal this. 1 minus 4x squared. Now my du over dx is going to be negative 8x. Now here's where it gets a little bit hard. Here's where you have to use some magic. Okay? You notice that what's left is x times dx. So I'm not just going to replace dx. I need to replace x dx. So when I ask you what is du, okay, how do I rewrite du? You're going to have to make sure that on the side of the dx, you're left with not just dx by itself like we did here, but it's going to be x dx. So first we're going to multiply both sides by dx. So we end up with du equals negative 8x dx. So I need this to stay together because that is what I'm replacing. I'm not just replacing dx, I'm replacing x dx. So I divide both sides by negative 8. So now I can rewrite my integral using my u substitution as the integral of, instead of x dx, it's actually going to be 1 over the square root of u times du over negative 8. Because you notice that now x times dx is replaced with this, and what's left on top is 1. So this guy comes out. So we got negative 1/8, the integral of 1 over square root of u times du. So remember that this is negative 1/8 of the integral of u to the negative 1/2 because it's on the bottom, du. So we add 1, it's negative 1/8 of u to the positive 1/2 divided by 1/2 plus c. Clean that up and then replace the u, so you end up with negative 1/8 times 2 over 1, u to the 1/2 plus c. This becomes 1/4, or negative 1/4 of the square root, because that's what 1/2 is, square root, and what was u? 1 minus 4x squared plus c. So there's my answer. I want you guys to check this. Alright, this is like the one that we did in class. This was easy. So u is 5x, du over dx is 5. But remember, we want to replace dx. So I want to get dx by itself. So I'll multiply both sides by dx, divide by 5. So we end up with dx is equal to du divided by 5. So now I can replace cosine of u times du over 5. I can replace that dx with du over 5. So that 1/5 comes out. So it's cosine of u du. And then we're left with 1/5. What's the derivative of cosine of u? It's sine of u plus c. And of course replace the u again. So 1/5 sine of 5x plus c. and then you can do the check. All right, some more examples. And just some more the procedures for using U substitution. So when using U substitution, you're going to replace a relatively complicated integral with a simpler integral. Change the original variable x to a new variable u that is in the function. Try to choose a u to be some function whose differential also occurs in the equation. Sometimes it's best to look to the most complicated part of the function to figure out what substitution to make. Finding the right substitution will take some practice. So find a u substitution, find dx, substitute into the integral, make cancellations, integrate, back substitute in for u. Those are the steps. Alright, so for this one, for example, the most complicated part is going to be in here. So I'm going to say u is equal to x to the fourth plus 2. So then du actually ends up being, or du over dx, actually ends up being 4x cubed. Correct? Now you notice here that we do have an x cubed with the dx. And I actually have an x cubed that I can replace with the dx. So when you're solving for this, okay, you don't want to just solve for dx. So when you multiply both sides by dx, you end up with du equals 4x cubed dx. So we want to keep the x cubed dx together. So I just want to move the 4 away. So we divide both sides by 4, so du over 4 equals x cubed over dx. So see, what our goal was is to be able to rewrite, so here's cosine of x to the fourth plus 2, x cubed dx. So what you notice here is that my u is x to the fourth plus 2, and this x cubed dx can be rewritten with du over 4. So now I can rewrite this as cosine of u, and instead of x cubed dx, I'm going to write du over 4. And just like always, this guy comes out the 1/4. So we're left with 1/4 cosine of u du. So this is 1/4 of sine of u plus c. And then of course you plug in the u, back substitute. So this is 1/4 of sine of x to the fourth plus 2 plus c. Alright, so here, which one are we going to pick to be our u? I'm just going to go with the guy on the inside. See, it's not a good idea to pick this one as your u because the derivative of that is just going to be 2, so it's not really going to help us. So our u is going to be x squared plus 1. So our du is 2x. So if I multiply both sides by dx, my du is equal to 2x dx. So what do you notice right here is that we can stop because what we wanted, so I got rid of my ugly function, but I also need to get rid of that. And 2x dx is right there. So if this 2x dx is now just du, then it makes it easy. So let's integrate. What's going to go in for x squared plus 1? It's u to the 50. And instead of 2x dx, what are we going to plug in? Du. So what is the integral of u to the 50? U to the 51 over 51 plus c. Done. So back substitute x squared plus 1 to the 51 over 51 plus c. There's my answer. And then you can check this by differentiating. Alright, see this problem right here And why don't you try to do it on your own before doing it with me? So press pause, try the problem, and then see if that helps. So first off, the hardest thing in here is the 8x minus 5, so I'm going to let that be my u. Now du ends up being 8, but over dx, sorry. So, but there's no 8 here, okay? But that's fine. I'm just going to solve for dx by itself. So I'm going to multiply both sides by dx. So this is du equals 8 dx. And I just want to replace dx. So divide both sides by 8. So du over 8 is equal to dx. So now the sine of u, and instead of dx, we're going to put du over 8. Remember, this is 1/8. So that comes out of sine of u du. So this is 1/8, and the integral of sine is going to be negative cosine of u plus c. So now back substitute in for u. So this ends up being negative 1/8 cosine of 8x minus 5 plus c. And that's it. We're done. Now, your homework tonight, right after these video notes, are to complete these problems. You're going to complete for homework with the checks. I want to see all the checks for each and every one. Okay? Enjoy.